Hello everyone and welcome to part 3 of the solution of GATE Chemistry 2022 on organic 1 marks questions. So here this question has asked that which one of the following compounds is the least acidic in nature. They have given us an alkyne terminal H, they have given us an alkyl carboxylic acid, they have provided us with a phenolic OH, and they have also provided us with a sulfur, that is a sulfonic acid, SO3H. So in this case, as we can understand that the alkyne terminal H is actually the least acidic, and this is the least acidic. This happens to be the least acidic, and the sulfonic acid group happens to be the most acidic. The phenolic OH actually then comes after the sulfonic acid in acidity, and alkyl carboxylic acid OH actually comes after the phenolic OH. So generally this type of acidity questions require to find out the pKa, but in this case the question was quite easy because they just needed the acidic order. So as we can understand that any sulfur compound containing the SO3H, the acids, or the even the aromatic sulfonic acids or the alkyl sulfuric acids are quite higher in acidity. After that comes the aromatic carboxylic acids, and then it is followed by the phenolic acidity, the phenolic OH acidity. After that is the alkyl carboxylic acid, and then comes the alkyne H acidity, so the terminal H of the alkyne. So this is the general order. Yeah. So thank you. So let's go to the next question. So the next question has asked us to find out the rate of the alkaline hydrolysis of the compounds shown below. So the compounds that have been given to us are containing tertiary butyl group in all the 3 cases. There are 3 compounds that has been given, and in the first one there is a CONH2 group which is above the plane, and the second one is a CO2ET group which is below the plane, and the last one is another CO2ET or the Nestor group which is above the plane. So as you can understand from the question that the amide group is actually the slowest hydrolysis reaction, because amide group is much less reactive than the esters. So hence we can actually understand that the ester hydrolysis being more reactive than the amide group, the ester hydrolysis happens much faster. So hence 2 and 3, these 2 compounds undergo hydrolysis rate much faster than 1. Now among 2 and 3, to understand, we have to actually draw the chair forms. So if we go ahead and draw the chair forms of the compound 2, which has got the ester group in the below plane, so then we see the chair form as you can see, and here also in the case of the third compound, as you can see, the CO2 group is above the plane, so it will be above the plane in the chair compound. Oh sorry, we have to the ester group is present. Yeah. So as we can see in compound 2, there is no significant syn diaxial interaction present, and because the H are above the plane and the CO2 is actually out of the plane, that is, it is present in the equatorial part of the chair form of the cyclohexane ring. So hence the alkaline hydrolysis is faster in this case because the intermediate is more stable, it's likely to be more stable. In the second case, however, there is extensive syn diaxial interactions among the axial H, because the CO2ET group is also in the axial position, the ester is also in the axial position, and hence due to this steric hindrance, actually the reaction is much slower, as the intermediate is actually less stable than the second compound, actually, so the second ester. So hence due to this, the second ester undergoes faster hydrolysis rates, and the third ester undergoes slower than the second. So the overall rate of alkaline hydrolysis as given in the question is 2 greater than 3 greater than 1. Yeah, so this is the answer. So thank you for following the videos, and keep practicing, keep writing organic chemistry reactions, and do well.